Thank you so much for joining us today. We will be talking about pattern analysis and the graph tool here at Persona. And before we get started, I had a few housekeeping items. And at the bottom of the Zoom chat, you will see a Q&A tab. If you have any questions about the content that we're going through today, please submit them there in the Q&A section, and we will answer all the questions at the end of today's content. And there's also a chat for other comments and technical difficulties. So put your questions in Q&A and then use the chat if you're not hearing us, cannot see the content, and for other things like that. And this session is also being recorded right now, and we will be sharing the recording with you through email at the end of the session. All right, cool. We will get started. First, I want to introduce the presenters for today's webinar. My name's Ashley. I am a fraud product analyst here at Persona. Usually my day-to-day is a lot of working with customers and account teams to help them build fraud solutions, but I also work pretty closely with the product and engineering side to help improve the core fraud product at Persona. And I will have Irfan introduce himself.
Yeah, thanks, Ashley. Hey, folks, I'm Irfan, product lead here at Persona. I work across a number of different teams here, including our link analysis team, signals collection and processing, as well as the end user facing flow and all the customizations there. So I'm excited to dive in. Yeah, I guess, Nisreen.
Hi, everyone. I'm Nisreen. I'm the head of policy and content moderation at Handshake. But I've recently took on basically building our fraud detection and policy work from the ground zero. So excited to talk through how we did that.
Awesome. Thank you, Irfan. Thank you, Nisreen. Really excited to have you join us today. Okay, going over the brief agenda for the webinar. First, I will discuss what pattern analysis is and when it should be leveraged for fraud detection. Next, Irfan will talk about the process and tips for building a pattern analysis tool in-house for your own business. And last but not least, Nisreen will talk about how Handshake AI uses pattern matching to find fraud clusters and build rules. So first, a brief introduction to pattern analysis. Today, modern fraud attacks are often very coordinated, where a group of users will often share common resources, tips and tricks, and techniques that are the most effective for the business they're going after. For example, if your business is in the gig economy space, a common baseline risk that you will see is users sharing the same accounts, sharing the same devices, or maybe users with fabricated driver's licenses and auto insurance documents. And on the IDV side, we are able to collect the corresponding signals whenever a user goes through a verification, which could look like at Persona, a selfie, and a GovID image. And Graph is the link analysis tool here at Persona that we use to identify these signals across the verifications. And one example of what fraud could look like nowadays is maybe you'll find that one user has opened 10 new accounts suddenly in the past 2 days. And if you look into the verifications that they submitted, you might see that their government ID is showing signs of tampering. And from this verifications, we can collect signals that could look like device tokens that are shared with other accounts or IP addresses that are located outside of the business area. And Graph, again, is a tool that we use to connect all of these accounts and analyze all the signals that we're able to collect from the instance of the user interacting with us. And when evaluating verification attempts or when we're doing fraud analysis, usually we like to talk about a layered approach. So there are 3 layers of analysis in fraud here at Persona. The first layer, the base layer, is the image, which is usually the selfie images that we collect from the user and the government ID image, the document image, etc. And here is where our ML models will run. So our ML models and automated verification checks will be able to automatically detect things like digital artifacts from Gen AI or fabrication on an ID. And the next layer is the environment layer. And this is aside from the visuals of the government and government ID and the selfie, how the user is actually completing the verification. And this will often include things like device signals, network signals, geolocation, like where is the user located in the world when they're completing the verification, and all of the environmental and metadata factors. And last but not least, most importantly, is the population layer, which is the link analysis that we're talking about today. And the population layer is how we're connecting users and connecting verifications that occur in our environment. And these are often shared attributes between users, such as two users could be sharing the same device fingerprint. They could be using the same browser. They could be using they could be standing in front of backgrounds that are very similar visually. So all of these are attributes that we will use in our link analysis. And detection also comes in three different levels. The first part is visual checks. For example, on an ID, we might look for a forged signature. We might look for if it's a valid template according to the year that it was issued. And we also look for signs of Gen AI on selfies. These are very good examples of our visual verification checks. The next type of detection are data verification checks or metadata or environmental checks. And this will look for content on the ID. For example, if the MRZ is formatted correctly, if it matches the issuer rules, and if the barcode extractions match what is on the front of the ID. And the third level of detection, again, this is a link analysis that we're talking about, is sort of looking for shared attributes between different users and different accounts. And this will help us catch fraud vectors such as identity muling, which means a group of users operating around the same time in the same space. And this will also help us catch very similar techniques when doing fraud attacks, such as injection attacks or a single user printing multiple IDs. And the attributes that we use in pattern analysis often look like device, image similarity, network, and many, many other signals that we collect throughout our inquiries. And today, professional fraudsters are very good. They often launch coordinated attacks that can circumvent the strictest, highest assurance flows. And fraud detection becomes very, very difficult. We often say that fraudsters just need to be right once to get through a system, but fraud detection needs to be right every time. And fraud is always evasive. An example that I like to talk about is in traditional ML, you might train a model to classify between cats and dogs. But in the fraud world, we can imagine that cats actually look different every day. Today, they will have three eyes. Tomorrow, they will have a very long tail. And the next day, they will have a very long nose. And because fraud is always evolving, we have to always adapt our detection techniques to be able to catch fraudsters at every level. And because of this evolution in fraud, and because it is very difficult to detect the very first attack that happened from a fraud ring, we often try to catch these fraudsters by catching their subsequent attacks. And doing so usually requires looking at the full set of information and not just simply at one verification. And the full set of information might look like where they're located in, what IP address they're using, or what device they're using and sharing with other users. And now I will do a very quick demo to look at Persona's graph product, link analysis product, and how we use the tool to build rules to catch subsequent attacks. Let me quickly share the dashboard. So here you're able to see at the Persona dashboard, and you're looking at a government ID and selfie verification that is created by one of our coworkers in a simulated environment. So all of these are fake. If you look at the government ID submission from this user, you can actually see that it is digitally modified. There are some digital artifacts, it's blurry, the address is fabricated, it's definitely modified either using AI or some kind of editing tool. And if you look at the actual verification, Persona was able to detect through the verification checks that this was an electronic replica. And what that means that is this user submitted this image through a virtual camera and not through a live capture. And we also caught it through inconsistent repeats, which means in this environment, there are other IDs with the exact same portrait, but with very different PII, such as names, birth dates, and document numbers in this environment. And while we have verification checks that can directly fail this instance, let's say I don't know if this is fraud, or let's say and I want to explore more about how scaled this fraud vector is, how many users are actually doing this in our environment. And something I like to do a lot is to just go to the account of this user, and then you'll be able to see a linked graph from this user's account. And in this graph, you can see that this user actually shares, is linked to 25 other accounts in this environment through many different factors. One prominent one is selfie similarity. This means that we could find other accounts in your business where they have the exact same facial biometrics, facial geometry. And another attribute that we can see here is device fingerprint and device token. And these usually means that this user is very likely using the same device and the same browser as all of these other users who are creating accounts in the environment. And after I see this graph, okay, 25 accounts are sharing the same device. I like to make an assumption that this could be a good rule to use globally to catch subsequent fraud. And maybe one assumption I can make is if 10 or more accounts are sharing the same device, then it is likely fraud because a good user, usually regardless of what industry your business is in, a good user would not be very likely to be creating 10 accounts within a few days on the same device. So something that I can do once I have this assumption is to build that into a rule that can flag new verifications automatically. So in the graph tool, we also have this top-down search function where you can simply say, I want to find all accounts in my environment in the month of December 2025, where the accounts are linked on the same device token. And I can also change the threshold of how big I want the cluster to be. So right now I'm saying I only want to flag clusters of accounts when there are 10 or more accounts linked on the same device token. And after you run this query, you can actually discover that there are not just one fraudster that we saw, but 3 different rings that are doing the same type of attack where they create a bunch of different accounts using the same device. And using the workflow tool here at Persona, we can also very easily build this condition into a rule, and this will help you automatically flag any new inquiry, any new account that comes in that satisfies this condition. Awesome. And now I will pass it on to Irfan to talk about building a graph tool in-house.
Thanks so much, Ashley. Yeah, as Ashley mentioned, I'm going to talk a little bit about some considerations when building link analysis. These are things that our team thought through, and I know that obviously a lot of folks here have their own version in-house, and so I think it's always sort of an interesting thing, both to share kind of the types of considerations that we made, but then also things that we think are helpful just more generally for teams thinking about embarking on this type of analysis. 3 of the ones that we really want to highlight today are really sort of the real-time aspect, both with regards to availability and latency, image processing and text matching. Obviously, link analysis that can span many different types of, I guess, analysis that you're trying to conduct on your side. And so specifically for the type of fraud analysis that Ashley was showing, these are really the ones that we feel are important to zero in on. Starting with real-time availability. Obviously, fraud happens extremely fast, and in order to be able to stop it, this type of analysis needs to be run instantaneously before the user actually gets access to what the fraudster gets access to what they're trying to do. And so for this, we run all of those queries that Ashley was showing in real time, either during the end user facing flow. So for instance, after they submit their government ID or after they submit their selfie, and then branching them up to higher friction flows interactively. Or, for instance, we'll do this immediately after the user submitted all their information and be able to quickly decision off that information before, let's say, they go back to whatever app it is that they're trying to actually access. Now, doing this for link analysis presents special challenges. Link analysis is often very, very slow, with queries potentially taking up to 15 or 20 seconds, which is why a lot needs to be done to actually make this really fast. The other thing, too, is with regards to link analysis and graph databases in general, is that all queries are not created equal. And it's very likely that, for instance, you could have a query where it's connected to thousands, maybe tens of thousands, maybe millions of nodes, where issuing the same query on one account versus another account could result in a totally different profile in terms of the memory usage, the compute usage, everything. And which is why a lot of consideration needs to be taken into account when building something like this. For instance, either, let's say limiting the type of results that you get back for a more consistent response, or something that, for instance, we do is, for instance, always provision high availability clusters of our graph database to make sure that even if, let's say, one is completely strapped and processing a very intense query, there's two other nodes that can still handle traffic. There's a lot of things here, and is something that our team has been working on for the past like 5 or 6 years consistently. And still, there are things that we really need to, or really feel that there would be a lot of benefit to do. So again, something definitely to consider. Uh, for IDV, and I guess just sort of fraud in general, something that Ashley showed and is definitely been a key challenge, but also something that has been sort of worth the challenge here has been finding repeat images. Obviously, the most naive way to do this would be to look pixel by pixel and be able to see if somebody just put the same image back through. Now, obviously, fraudsters are smarter than that. And so we've turned to vectorizing images, both with regards to biometrics and with more general embeddings to understand similarity between images. This greatly complicates the previous point with regards to doing this all in real time because the image needs to be submitted, vectorized, compared in a vector database, and then also then added back to an adjacency list to understand what are the connections and maybe also connect that back on device or IP, for instance. The last one that I'll call out before we kind of just speak more generally and then pass to Nisreen is also with regards to normalization of basically everything that goes into the graph. This is maybe a generalization of the image point made earlier, but we go through great care to normalize and also allow customers to create their own normalization for instance, like let's say strings that you want to compare. So the most classic example here is with addresses. In the US, we run USPS address normalization to make sure that if somebody types in one persona street versus one persona ST, that normalizes back down to the same address. This is kind of commonly referred to as like address tumbling or email tumbling when somebody would create multiple different aliases for the same email. Irfan.df versus irfandf@gmail.com. Same email, same inbox that it routes to, but if you're not doing the text matching, you'll not find the connection between those two users, and fraudsters know that. We provide a number of different other things like Levenstein edit distance, soundex, so on and so forth, and are constantly sort of trying to innovate in terms of bringing that data engineering into the tool so that people don't need to build this themselves. Those are just a couple of the considerations, but obviously there's a lot more. If anybody, there's nothing else true about link analysis, it's that it is complicated. And so with all that, the at least on sort of the back end of that, with all of that effort does come reward. As Ashley mentioned, we found it to be extremely helpful in fighting scaled attacks within your organization. Obviously, the first attempt is one thing, but we often see fraud try to scale to the hundreds or thousands, and we take great pride in being able to help organizations block every sort of subsequent attempt with Graph after that first one, and many other different tools for even stopping that first attack in the first place. The last thing that I'll call out here is that if you're a current Persona customer and you're interested in connecting your graph across organizations and most importantly, have a data sharing agreement with other organizations or the ability to share secure fraud data, that is something that we are starting to roll out for organizations who opt in. And we'd love to chat about it more. Even if you're not yet a customer, this is something that we can also talk about as well. With all that, I will pass it over to Nisreen to talk a little bit more about Handshake, how to use Graph.
Hi, everyone. So if you're not familiar with Handshake, Handshake is originally was a basically LinkedIn for college students. So it's really focused on early careers and helping um, folks who just graduated college um, find their careers. We have also now just launched in the last year a business called Handshake AI, and it kind of supplements our original business of helping college and early careers get into the workforce by kind of introducing them more into like AI work specifically. And so the idea of Handshake AI is that we contract skilled knowledge individuals or generalists to work basically as data labelers and improve the output of LLMs through like contract work. And then hopefully that could help lead to more work within AI or like wherever the field they're interested in. So a little overview on Handshake AI and why I think it's a high value target for fraud. I mean, prior to this, like a LinkedIn, we might have had some fraud, we had some employer fraud, but not to the scale of what is happening now. And I think it's due to it's a well-paid remote opportunity that you just apply online, you don't have an interview, you don't have to come into office, and all your work is remote and mostly off camera. And so it's an easy way if a fraudster can get through our security checks to basically make money off of our us and our platforms. When we do hire for people, we're trying to hire for experts. So a lot of the projects we have are for like PhDs in chemistry and engineering and physics. And we source from a lot of our universities. We have 1,600 plus university partnerships. We have trusted job boards. But I think a lot of common fraud we are seeing now with Handshake AI is people are coming in with like fake academic credentials saying they have a PhD from Harvard when they in reality do not. They fabricate publication history, they steal or manipulate identities, and they reuse or take fake selfies. Persona has been really a key in our verification layer for our fraud detection. It's helping confirm applicants are real people and their identities match the credentials they're presenting. So like using real IDs, things like that. So we use Persona to verify government IDs, run liveness checks, surface identity risk through early in the onboarding funnel, like through IP, VPNs, things like that. Obviously, Persona is not a single pass-fail gate for us. It's a combination of internal signals like IP, impossible travel, account behaviors, and then we do our own credential validation of like, did you actually go to this university? Do you have a PhD? So we're kind of looking for two things, like, are you who you say you are, and are your credentials real? Next slide. So our identity verification requirements are designed to stop like the sophisticated digital fraud that Ashley and Irfan were talking about. So it's not about just basic impersonations. We have detected people who use manipulated and synthetic media like deep fakes, fake filters, and AI generated images. It's really wild actually because they come through Persona and they look so real that unless a human eye goes in and checks on those, you would think that they would pass. We verify liveliness, catching pre-recorded and replayed videos. So sometimes I'll see videos of people taking a picture of their ID and they'll use the front of one ID and they'll take the camera and move it to the back of another ID. And so the ID seems real, but if you actually watch the liveness video, you'll see that it's a fake ID. We do identity checks paired with strong fraud signals like device fingerprinting and IP analysis. We track and block repeat offenders. So if people have like selfie repeats, device repeats, or submission patterns that are suspicious. We also identify and coordinate fraud at scale. So like not trying, like kind of going to the product that Irfan was talking about with Graph. It's not about leveraging just one person, but like leveraging like graph analytics to surface connections. Because a lot of times with these fraudsters, it's not a single person, as I think Ashley mentioned. It's like a ring of people who are coordinating together. So all these signals work together, allowing us to automate enforcement and proactively block future fraud attempts within Handshake AI. Next slide. So this is a really gnarly graph that I pulled because I just think it's such a good example of kind of the fraud that we do see. Detecting fraud networks, not just individuals. Like you can see how many people are using a single device, how many of them are using the same IP, and how they even branch out to other IPs, but they're all tied together. One thing that I learned, like, prior to working on Handshake AI fraud, I did like content moderation, so very different. Obviously, there's some fraud there, but one thing I really realized in this job is that like fraud rarely happens in isolations. It's like very coordinated. It's usually a lot of the same actors attempting to create and control multiple accounts. Persona's graph feature is like one of my favorite features of Persona that we use because it really lets you see connections across accounts, even with individuals who like on their own look legitimate. You're like, oh, this person's fine. If you look at the ring, that's really when you're going to see, or the graph, you're really going to see where all these connections lie. Um, and it helps us to identify repeat offenders and also fraud rings early. So like as soon as like, they're all sharing this one IP, it's very clear if three or more people that we've deemed as like fraudulent, we can know that that whole IP address is one that we would want to put on like a suspicious list. Um, and then I would say graph turns individual risk signals into network level risks, surfacing patterns that would be difficult to detect through manual review alone. So I always have all my agents make sure they look at the graph for every single person they're looking at. And when we identify these high risk clusters, those signals feed directly into our trust and safety network workflow, and so we can do bulk enforcement. So again, we can catch multiple fraudsters at once versus one. And it just results in a strong fraud prevention at scale. This also allows us to act proactively, blocking entire fraud rings rather than reacting to individual bad accounts one at a time, which obviously, if you are familiar with fraud, you're like kind of playing whack-a-mole, trying to catch all these guys. So uh, the graph tool really helps us like visualize all of them and you can kind of hit everyone at once.
Awesome. Thank you, Nisreen. Now we're going to move on to our Q&A section. If you have any questions, please continue to submit them into the Q&A section, and we'll either answer them live, or if we don't have time, we can get back to you through email or through your account team if you're a Persona customer. So one question here is, for visual verification checks, how are you checking for signs of Gen AI? Or rather, what sorts of things are indicators of Gen AI usage? So on the visual side, we do a few things. One of them is just simple classification, and the other thing is we look for some specific factors, such as digital artifacts, watermarks, boxing, if the person is floating, if their body looks stretched, and all like different kinds of specific factors. So we have a bunch of different models for deepfake detection. But when I am like as an analyst looking at Gen AI selfies by myself, a lot of times I also like to look at what's happening in the background, because a lot of models today, is very good at generating the face, but they often use like outpainting techniques to generate the background, and things will be distorted and they do not look real. But and but today, obviously, a lot of Gen AI can be really, really good and very difficult to distinguish visually. So what we also like to do to ground truth is to run video verifications, which means while the user is completing a selfie or Gavadi verification, the user flow is exactly the same, but we're just recording a video in the background. And then we can do some looping detection, movement-based detection, and it is also very helpful for visual ground truth, where we can, see if the facial expressions are natural. But with that being said, like Gen AI today is getting super, super good. And there definitely are cases where we just, even humans cannot distinguish that it is Gen AI. So I think the technique, detecting the fraudsters technique is also super important. So we also do a lot of virtual camera detection. If they're doing Gen AI, they have to replay it to us somehow, and that is usually through virtual camera, a rooted device, and we through that we will be able to collect signals from their device properties, camera properties, and other things to detect that they aren't doing a live capture while replaying the Gen AI to us. Um, Another question, I think maybe this will be better suited for Irfan, is how are you capturing the device ID when you talk about device repeats?
Yep. Happy to cover that one. Um, at Persona, we have a number of different device sort of ID techniques. It definitely depends a little bit on we understand that every customer and every use case has its own tolerance for recall and precision, and thereby we sort of offer multiple different types of device IDs there. So, for instance, on web, where it's quite easy to manipulate the browser and it's hard to access information about the underlying device from the browser. We offer you know, the classic sort of deterministic cookie-based type device ID stuff that is like extremely basic, but then beyond that, device fingerprints, one that's focused on precision. So very high likelihood that if you see another user with the same device fingerprint, that it is indeed the same uh, user that has come back, and then one that is more focused on recall, where it might show you matches where it wasn't actually the same person. Obviously, it's factoring in hundreds of different attributes about that user's browser, the extensions they have installed, et cetera, so on and so forth. But at least you can be much more assured that this is going to be capturing perhaps like all possible matches. Obviously, if two people have a factory reset Safari latest version browser where they haven't done anything and they're using either the same IP via the mobile tower or on the same like corporate network, for instance, that they can be falsely grouped together, and it's kind of just a hard problem. But at the very least, it's good to have sort of some control over what type of device ID you want to use, whether that's recall focused or uh, precision focused. And then very sort of similar story for mobile SDKs as well. Entire set of different device identification. So hopefully that helps. Another thing I'll call out is that for Graph specifically, that use case, but perhaps also more generally, we did also recently launch a way to capture the device ID outside of the identity verification flow using a product we call Sentinel. This will help, for instance, folks who want to run that type of graph analysis outside of IDV, either before to understand whether you want to step that user up to IDV or after to make sure it's the same device that IDV that's then going on to use your platform. So I hope that helps, Adam. And yeah, always excited to chat more about it.
Awesome, thank you. Um, I have another question. Can you please provide another example of a time when link analysis confirmed something that verification checks didn't? Um, I think a very good example is discovering identity muling, or we also often call it identity farming, which is when one bad actor wants to create a bunch of different accounts. It's usually, easier, more trustworthy to just grab people off the streets, like to literally get other people verified for them. And you'll see that these verifications are almost like first party fraud, where their government ID is real, their selfie is real, they're being live captured. But when you perhaps look at a graph, you'll discover that maybe they're all standing in the same room, or they're all dressed very similarly and they all work together. And a signal that could link these folks could be they're sharing the same device. Like one fraudster is literally going around the streets to pass their phone to other users to verify themselves. And something else that could link them is image similarities. So sometimes they're all just sitting in the same office, and you can say the exact same backdrop across these user verifications. So all of those are super interesting to discover in Graph because just looking at one instance of the verification, you cannot tell that it is fraud because it is a real identity and a real human behind the camera. And the next question, I think it's also probably more suited for Nisreen. How did you prioritize the evaluation of persona versus 1 month later or 3 months later after you started using persona with regards to Handshake AI's business or user sign-up growth?
Yeah, so I think we already use Persona in-house for our Handshake career business, where we use it to validate employers on our Handshake career business to make sure they're like legit, real employers. So we already had a relationship. We already knew how the tooling worked. And so when Handshake AI launched, we thought, it made sense to continue our partnership with Persona and lean in to Handshake AI and do ID verification and selfie checks for candidates who are applying for Handshake AI. At first, like I mentioned, I've done mostly content work and policy work, so I was new to like really fraud operations when I took this on. So I think one of the biggest things that was a learning for me was like I was thinking it was very similar to employer side where we're just validating each individual person, whereas you see 3 months in we really realized about these like fraud rings and that they are coordinated attempts that like this isn't just one person trying to like make money on the side and like use it with their friends or like huge rings of people in Kenya or Pakistan or other countries who are trying to infiltrate and like kind of get into these US job markets. And so 3 months in really was about like adding more tooling into our persona detection, not just using basic like selfie and ID checks, but like thinking about all the other things like selfie liveness, IP address analysis, impossible travel, network level threat. And then, even now we're thinking about adding even more of the features that Persona offers, like email and phone number risk analysis and things like that. So I think like we discover new, as fraudsters realize more vectors of way they can infiltrate our system, it's really great to work with Persona. I'll say that Persona's like the folks that we work with are really great at giving us guidance and helping us know which toolings to implement to kind of help us catch these fraudsters faster.
Thank you, Nisreen. We have another question. I work in the banking industry. Could the ID validation tool identify a counterfeit ID being presented in person if we took a photo and uploaded it? Um, I think the short answer is yes, we can a lot of the times. Um, so if you take a photo of the ID and uploaded it to Persona, we just have, out of the three detection methods we discussed today, we just have the visuals. So we have a lot of visual checks and content checks on the ID that could spot a counterfeit ID, for example, scanning the barcode, if the barcode information matches the front of the ID, looking at the issuer rules of the ID, looking at the format, etc. So we do have a lot of verification checks that can spot a fake ID. However, with that being said, um, just sending over, like having the user upload an image or sending over an image to us through API means we lose a lot of the and device signals and network signals, and all of the other array of signals that we can collect from the user capturing that ID live. So we don't know what kind of device they're using. We don't know what camera they're using. We don't know if they, photoshopped it before they uploaded it. So a lot of these factors will definitely make the detection more challenging, and which is why we always recommend customers that they have the users capture the ID live instead of uploading it or sending us over an image.
Yeah, I think just plus one to everything Ashley said there. I think between the combo of checking against the various databases, be that the DMV via AMVA, or our portrait tampering check. Let's say, for instance, it's a valid combination of PII, perhaps from a leaked license, but then a portrait that's grafted on. We have specific checks to check for that and the different ways that folks might achieve that, either on a printed fake or by tampering with that specific element individually. That is a specific vector that we do track and have many different sort of levels of verification depending on what the customer's interested in.
Okay, I don't think we have. Oh, actually, um, there is one more question. How can I get in touch with Persona? And please feel free to reach out to us through email. I'm sure there's a request demo option on our website, which is withpersona.com. And we're happy, like our sales team and our marketing teams will be happy to connect with you. Um, and yeah, if you have any other questions about today's webinar or about Persona in general, please feel free to reach out to us in any way through email. If you are a Persona customer, you can also reach out through your account team, and we'll do our best to address all the questions. Yeah, thank you so much for joining us today. Hope this was helpful, and hope you'll see you again.